I'm an African warrior, African prime, African time, it's about time. African native, I'm a sub-Saharan native. Time to shine with a distinction, get 100 easy, man. Let's get started, man. So, my name is Hamish, but a lot of people like to call me 25 Batida, 25 Batida. Let's get started, man. So, question number 4, paper 1, 2018. You know what I'm saying? So, in the diagram below, the graph of f of x equals to ax squared. Oh, so this is a function, right? Oh, yeah. So, now if it's a function, whenever you have a function this format, like if somebody give, let's say f of x means function. Let's say they give you a, oh, that's not right. Okay. A x squared plus bx plus c is a quadratic equation. Means c could be any number, let's say 5x squared. Let's say b could be any number, let's say -3, means our b is -3, and they have x, and here can be 7, means our function is quadratic. So for this case, when they say ax squared, means there's nothing here is 0 and 0. In other way, this b equal to 0 and c equal to 0. So you only have that, means that. But we don't have a, you know what I'm saying? We don't have a, so now, okay, another thing is when this number is positive, means your graph is gonna concave upward. When this number is negative, let's say -3, means our a is, let's say x squared. What is our a? A is the number before x squared. Means this number here, if it's negative, means it's gonna concave downward. So for this case, we don't know. You know what I'm saying? But let's say graph of f. So what is the graph of f? It means this. Oh, so roughly, we know this a is gonna be negative. You know why? Look, this graph is like this. Look, cut there. But it's like they did not give us the full. They only give us one side. It's like they hide this side here. So I know by any means my a is going to be negative number. Or in other words, a must be less than 0. Because negative number less than 0. Oh, okay. Because this is f. They say f of x means this is f of x. But that did not means, okay, so it's like this. Because y is less than 0. So now, if they did not means, the thing is they did not draw left and right. Means they only draw on the side of the x on the left. Means they only draw on this side. Means when x is less than 0. Means from here to the left. But if it was drawn like this, means the graph was still going to be f of x, but it was drawn when a means x are greater than 0, positive side. But for these cases, negative side including 0. So I can just say this must include also 0. Means this graph was drawn on this side. But if it was like this, we say, oh, let's say this is g of x. So the graph was going to be what? It was drawn at the x greater, or when we say greater or equal, because it was on 0. It was on 0. Okay, now let's go. So it drawn an interval of x less than 0 means on the left, means not everywhere. But if it was everywhere, then we could have said x, it was drawn everywhere in the value of x, means at x is real number. Element of real number is x. Element of real number. But for this case, though, they did not give that. Now they say also we have the inverse. Man, listen here, man. What is inverse meaning? Okay, I want to break down for a lot of people here. Some people don't know what's happening here, man. Woo, woo. So daddy. Okay. Okay, so now if somebody say inverse, look, if you got a graph like this, say, okay, let's say there's a graph here, roughly. Oh my god, it's too wet because my eraser was wet. Okay, somebody give you this. Let's say for example. Okay, now we want to reflect this. It depends how you reflect. If you reflect on x means this is, okay, whenever you say reflection, what is the reflection? How we use it in real life? It's like a mirror. If I'm here and then if the mirror is here, I'm going to see me on the other side. You know what I'm saying? If I'm here and like I'm checking there in front of me, there's a mirror, I'm gonna see me other side. You know what I'm saying? So the reflection is like a mirror. You know what I'm saying? So it depends on your reflection, x or y. So according to this, if this is our f, so this is f dash. What does that mean? Excuse me. They say the graph of f dash is also drawn. No. It's not reflection. Apology. They just say is f inverse. I kind of went so fast. Come down. So we want to get f inverse. They say f inverse is given, means the inverse of f is this. But if you look careful, it's like like other way around. Inverse is like other way around. So if this is f inverse is here, it's like da, 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 da. Okay. So now let's say if you look careful, we have a point. This point is on f. You know what I'm saying? This point is on a f is on a f. And this also, we have a point r, but we don't know the coordinate of r. What do they want? They say it's f inverse of a function. F inverse is the function. Okay, what's f inverse? They want us to test if this is the function. You know what I'm saying? How do you test a function? You test any function by drawing the vertical line. If the vertical line cut once, then it's a function. Okay, now, for example, if this is a function, let's draw a vertical line and see. Look. Oh, it cut only once on the graph. Yeah, it is a function. See, if you draw it, you see it cut once. Oh, this is a function. So this is quadratic function. Because why? The graph, when you draw vertical lines by vertical test, it only cut once at every point. For example, if somebody asks you, is this a function here? Excuse me. No, this is not function. Why? Because if I draw vertical line, it's gonna cut more than once. Look, it cut here and there. It has, when you draw a vertical line, it only has to cut once. So this is not function. Why? Because the vertical line cut more than once. So for this case, the answer, what did I ask? Is the f inverse function. F inverse. What is that? Oh, this is the f inverse. Now let's draw a vertical line and see. So don't worry about the f, right? We just assume the f is not there. Now we draw. Oh, it's gonna cut only once. Assume the f is not there because they didn't ask about f. No, just f inverse means this graph here. Oh, it only cut once. Yes, it is function. So the answer, yes, it is function. So this gonna be answer here 4.1. Yes, it is function. It is function. How did you know that? Because of what? Vertical line test. Because of vertical line test. By vertical line test. So I'm gonna raise this again. By vertical line test. I'm gonna go quick a little bit. Vertical line test. You know what I'm saying? Okay, let me ask you, this function here? No, it's not, because if I do vertical test, it cut more than once. So cycle is not function. You know what I'm saying? Now we got it. Now we go. Okay. 4.2. Another thing. Sometimes they're gonna ask you, is it one-on-one function? So you know one-on-one function is not part of the question, but I want to give the overall. How do you know function is one-on-one function? Okay, cool. So one-on-one function, let me write here. It's not part of the question, but one-on-one function, I want you to understand everything. One-on-one function. Okay, face. Before you test one-on-one function, it must be function, face. You know what I'm saying? So now, somebody ask you this, let's say, it is one-on-one function. So first and foremost, don't start for, oh, let me think about one-on-one function. No! You know what I'm saying? Let's just go first and test if it's function. And then we're going to think of one-on-one. Okay, let's test if it's a function. Oh, yeah, it's function because it cut once by vertical test, vertical line test by vertical line test. So now after you find out the function, you say this is the function. This is the function, apology. It's a function. So after you find out the function, now we can test one-on-one function. How do you test one-on-one function? One-on-one function you test by horizontal line. Horizontal line must cut only once. Now let's go horizontal line. Oh, it cut once, so this is one-on-one function. Yes. So don't just run and say, oh, this is one-on-one function. Some of them, they cannot be. For example, let me give an example here. Something which is gonna be, okay. So this is one-on-one function because why? When you draw horizontal, it cut only once. Okay, now. Okay, so this is x and this is y. It is one-on-one function. So first, don't start testing one-on-one by horizontal line. No, test if it's a function. Let's see. Is it a function? Oh yes, it's function because it cut only once at vertical test. Now you go for horizontal to test if it's one-on-one. Let's go. No, it's not one-on-one because when you draw horizontal line, it cut more than once. So to test something one-on-one, you must test by horizontal line test. But before you test for one-on-one function, make sure you test if it's a function, baby. You know what I'm saying? Oh yeah, so we're done with the first part. Anytime they ask you next time, you know you saw them. Now we go for number 2. So number 2 shows, oh my God. Number 2, they're asking, How did I ask these people here, man? They say it's R reflection of P. Okay, now let's go check if it's R reflection of P. Yes, it is. Okay, let me explain to you about reflection quick. If you have a Cartesian plane means xy plane. This is y and this is x, and you have an A here. If you have A here, let's say our A equal to 3 and -2 minus 0.8. So if this is reflected on x-axis, so when they say reflected on x-axis, so this x-axis is like a mirror. So if something reflected here on x-axis, where it's going to be? It's going to be under here because this is your mirror here. You know what I'm saying? It's going to be reflected here. So if you look careful, look, the value of x is going to be the same, but the y is going to change. It's going to be, oh my apology, I'm wrong. There's no way this is going to be negative. Okay, positive 2 here. You know what I'm saying? Means if this is, it's reflected on x-axis, means this is going to come down, so x is going to be still positive, but the y is going to be -2. Now we check this one. And they will reflect here on a y-axis. So y-axis is like your mirror. This is the mirror. Now we go. Okay, so what happened to the x? X is going to be negative because this side is negative. But y is still going to be 2 because the value of y here is the same in the horizontal line. You know what I'm saying? So that's how the reflection works. You have to pay attention on either x or y. And that's going to be your mirror. So now we come here. If you look careful, this is f. So the inverse is like other way around. So if you look, if this, look. It's like you switch the value. So the value of x, look, there's no way, if this p -6, there's no way this is going to be -6 again. This is going to come here, but remember, the value of x is negative still, and the value of y is negative still. But this is going to come here, it's going to be -12, means this is going to start first, and this is going to be -6. You know why -6? Because the value of x is still negative, and the value of y is still negative. Any point here, the value of x is negative and the value of y is negative. But why do we switch? Whenever you inverse things, means x is going to go in y and y is going to go in x when you do inverse. Thank you, my apologies. Okay, that's when you do inverse, means other way around. Switch them. So I'm going to switch here and this I'm going to switch. And on top of that is obvious. Everything here is negative. X is negative and y negative. So, oh, okay. Is that a reflection of P? Yes. It is. You know what I'm saying? They even say here, y equal to x, means you have to change. This is x and this is y, means you have to switch them. The y has to come to x and x has to come to y. Oh, so yes. So mean this our r also -12 and x equal to -6. You know what I'm saying? And you can see here the value of x is more and the value of y is kind of decreased. Look at this point. The value of y decreased, but the x is getting more to the left. From here, it went a little bit more to the left. Okay, even though the graph was not drawn scarp. Now we go for 4.3. 4.3, let's say find the value of a. Find the value of a is very, very easy, man. So first and foremost, look, think, where is a? Oh, a is in a function f. So go to your f. Where's your f? This is my graph of f. So if this is f, whenever you have a coordinate, see this coordinate? It is on f. So it's acceptable. You can take this coordinate and put in a equation of f because it lies on f. But if they say, oh, about the f inverse, so you could have taken this of the f inverse, put in the equation of f inverse. But it's not f inverse, this is just f. So I'm going to take that because it lies on f. This one lies on f. So I'm going to say, oh, so 4.3. I'm going to say, okay, so this is x and this is y. So instead of saying f of x means y. So I'll say, okay, this is going to be -12. I'm not going to write something -12 because f(x) meaning y equal to I don't know. What is my x? X is -6. So -6. But what happened? You square. Oh, okay. So this is going to be -12 equal to -6 square. This is going to be a, and then this is going to be 36. So I want to get the value of a divided by 36, divided by 36 to get the value of a divided by 36, and then divided by 36. So what happened then? And then this cancel. So a equal to -1/3. -1/3. Oh, so we're done for 1.3 is -1.3. So if that's the case, then I can rewrite my function. You know what I'm saying? I can rewrite my function. So my function finally, this f of x, I'll rewrite a. Okay, I know my a. What is my a? -1/3. And then what happened? X squared means this must be x squared. So this is my a. You know what I'm saying? Now we go to the next. And then so write down the equation of f inverse. Oh, so the one equation of f inverse. Remember, now we go. So if you want to get f inverse, it's very, very easy. So that's 4.4. Okay, you want to get f inverse, is very, very easy. I swear to God. Okay, let's get f inverse. F inverse is very, very easy. How you do it? Now, whenever you find the inverse, the inverse of what? Of, for this case, of f. See, this means inverse of s. So take your fx, which we have already just found now, f of x equal to negative 1 over 3 x squared. Excuse me, let me raise here to next phase, so I won't bring a lot of confusion to you. Say, oh man, I'm confused. No, you wrote a lot of things right there, I can see. And it's easy, man. You know what I'm saying? So now we have these f of x. Now, whenever you do inverse, you have to replace. You see, this is meaning y. Whenever you say f of x meaning y, this is like a y. When you say f(x), means like saying y. This is like a y equal to negative 1 over 3 x squared. That's meaning f of x meaning y. So now whenever you mention inverse, in the position of y, write x, in x, write y. Okay, so remember, this is going to be what it's going to be. So say for inverse, whenever you say for inverse, means you have to replace. This is y is going to become x, and this is x is going to become y, negative 1 over 3 and then x squared. So now how are we going to get x squared? So we have to make this up. What am I doing? And this x is going to become y. My apology. Okay, so we want to make a y subject because now it's the inverse, so make y the subjects. So now come put this over 1, say 3 times x is going to be 3x. You know, so now, and 1 times negative is negative, means you cross multiplication. 3, this times this is 3x. 1 times negative 1 is negative 1, but we have a y squared this side. Okay, so now make the y subject. So divide by negative 1, divide by negative, because we don't want this negative 1. We just need y alone. So divide by negative 1 this side, and this side divide by negative 1. So now we're going to have y squared. I can just finish up here. So y squared equal to 3x divided by negative is going to be negative 3x. So now, since you want to get y alone, you have to square it throughout because you don't need y, you just need y. So you just need, you don't need y squared, you just need y equal to square root of 3x. Oh, so the moment you make these the subjects, call this f inverse for this case. So f inverse, now put x here because this is x, equal to square root of negative 3x. You know what I'm saying? But there is something here I want you to note. It's very, very important. I have to give you a condition here, baby. You know what I'm saying? So the condition is, look, whenever you square, or whenever you have a square root of anything here, excuse me, you have a square root of anything, let's say 2x minus 1. So I got the equation. So now, erase that 2x minus 1. You know what I'm saying? Erase that 2x minus 1. For example, if somebody, okay, let me say this. If somebody give you 1 here, can you square root if you put 1? It's going to come. Take your calculator, say square root of 1, it's going to give you. Put 0, but I put negative number. Say square root of negative 3, it's going to be, oh, error. Square root of negative 9, error. Why? Because anything which comes inside the square root, it must be either 0 or more than 0. So if somebody give it like this, they say, oh, so when this function can be defined, so for the function to be defined, anything, so don't take that number inside. Please, 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 man. Come on, man. 100%, man. So take this one here, whatever is in here, say, oh, what is in this? Everything, please don't look at, this is x, this is 1. What is everything? 2x minus 1, it must be greater or equal to 0. Means anything inside the square root, it must be either greater or equal to 0. So please don't look like x must be this number. You're not gonna get right, okay? So now I'm saying, oh, and then after that take over. So this is gonna be 2x greater or equal to, and this one is gonna go over. So divided by 2, divided by 2. So x must be greater or equal to half. So that's your domain. So for this function to be defined, the value of x must be greater or equal to half. Do like that. Okay? Don't say which number should I put there? Which number should I put there? You know what I'm saying? It must be greater or equal to half. Even if look, it must be greater or equal to half. For example, equal, or if I put 2, because 2 is greater than half, put here. 2 times 2, 4. 4 minus 1 equal to 3. You can square it. Now let's try a number which is less than half. For example, 0. Look, if you put 0, it's going to be 2 times 0, 0. Minus 1, negative 1. Square root of negative 1, problem. So do like this, please. So I'm going to do the same thing here. How I'm going to do, say, okay, I'm done with my question, but I'll say everything's here. we know must be greater or equal to 0. Okay, so now I want to write the condition. So I'm going to say negative 3x, it must be greater or equal to 0. So what I'm going to do, divide by negative 3, divide by negative 3, divide by negative 3, negative 3 is in this constant. So x in inequality, whenever you divide by negative number, the direction of the inequality must change. You know what I'm saying? It got to change. Okay? It has to. So if I divide by negative 3, you see here, divide by negative. This is facing on the right, it's going to change the direction. 0 divided equals to 0. Make sure you do that, okay? Only when you divide by negative number. So now I'm going to say, oh, so my condition here, even though I'm done with the inverse, then I must write this next to it. So x must be less or equal to 0. But how did I get there? Because of that. Also write them part of the solution. Let's say, write in the form of, so in the form of, this is going to be y, finally. I can write even here, or here. So I'm done with everything, so I can say y, right away. I say y, finally. No, let me write there. So finally, so y equal to square root of negative 3x, but our condition, x must be less or equal to 0. Listen, man, it's African time, African prime, I'm a warrior. Time to shine with distinction, I'm a sub-Saharan native, get 100, easy, man. Easy, man. We got it, man. Let's go to the next question, baby. We're done. Thank you. I'm out.